Right, we got thumbs up to get going, so welcome everybody to this first session on the topic of maintaining and developing Arctic observing capabilities. My name is Arild Sundfjord. I'm with the Norwegian Polar Institute, and together with Øystein Godøy from Met Norway and Chantal Verhey from, that's embarrassing, University. Carleton, thank you. Ilkar Fehr at the University of Bergen and Jan René Larsen from AMAP. We are convening this session today and tomorrow morning. So for this session today we have one keynote and 6 other presentations, providing really a broad overview of different methods and ways of observing and understanding observations. And then tomorrow we have another keynote and 3 presentations that will be a bit wider in scope, in the sense that they might be more pan-Arctic in their scope, whether it's data management or observational collaboration or cohesion. And we will also have a panel discussion tomorrow, trying to bring together these different perspectives and together look at ways forward for Arctic observing from large to small, or the other way around. So with that, I am very happy to introduce our first speaker, Mikael Kercher from the Alfred Wegener Institute, physical oceanographer by background and well known for leading the recently concluded and very successful EU-funded project Arctic Passion.
Yeah, thank you very much, Arild, Øystein, and the other organizers for having me here and talking a little bit about Arctic Passion and our, let's say, summarizing or synthesizing thoughts on what we have been doing the past 4.5 years. So when it's about the Arctic observing system of the future, how to advance the Arctic observing network, one big question we had to deal with was how to make it useful for the users. And I think that's something which we all will probably keep in mind for the forthcoming further developments of the Arctic observing network. So we are all aware we are facing dramatic changes in the Arctic environment and dramatic consequences for the people living here, but also outside of the Arctic. And this, of course, calls for the best available data and information we can get hold of to make knowledge-based decisions. And this then in turn calls for a well-coordinated, user-driven and integrated observing system of the Arctic environment. And the important part to keep in mind here is, of course, that we already have a lot of existing elements of the Arctic observing system. So part of the work is how to connect those in the best way to create something which was dubbed the Arctic observing system of systems. It's a bit cumbersome, this word, but it shows that we are talking about in place or which have some kind of independence. And we want to coordinate them as a community. And keeping that in mind, of course, we can think about these lots of components which are there. They range from community-based monitoring programs, indigenous knowledge, traditional knowledge, local knowledge, science. Then we have private sector data providers, we have data centers which are part of the system, research projects, indigenous peoples and other Arctic inhabitants, and so on, agencies. All of them are part of this network, up to the data users. The end users are also part of the network, and that's something to keep in mind when going forward. And then we have those end users also composing a large variety of people. Like indigenous people and other Arctic inhabitants, again, private industry, data centers, general public, policymakers, and so forth. So how to connect all this? Well, with Arctic Passion, we have tried to contribute to this network, to advancing it further, make it a collaborative effort. It was a big project. We started in 2021 and just ended this December after 4.5 years. We had more than 40 partner institutions, including indigenous communities from 18 countries. And the project is now reporting to the EU, and with that, we are trying to summarize our activities, and I come to that later on. So what have we been doing? We have been trying to contribute to a lot of the different topics and themes which are relevant in the context of an observing system for the Arctic, like enhancing the instrumentation and coordination, inclusion of different knowledge systems, enhancing the functionality of the Arctic data system. We have developed 8 new Arctic services, information services. I'll come to that later on. We have been piloting the concept of the shared Arctic variables as part of the Say on Roads process. We have been developing societal benefit analysis to make a business case more convincing to politicians and funding agencies why Arctic observing is paying off for the general public. We have been providing policy and decision-making support, and overall, we hope we contributed to developing a more equitable international structure and a clearer structure of Arctic observing. So just running through a few examples here in terms of enhancing instrumentation and coordination. We had intense support for the Interact network, a terrestrial network, which is where we supported 10 stations in the Arctic in harmonizing their data uptake in actual instrumentation and so forth. In the marine sphere, we have been developing new multidisciplinary deployments. A stronghold here was UIT and NPI here in Tromsø, who were leading this effort. We had new sensor and instrumentation and analysis development at the same time for the buoys, but also for the deep sea deployments. We have been working on improving monitoring of glacier runoff, but we have been also active in the coordination activities, and you will hear a bit more about that later on from Jackie Grabmeier on the DBO system, so I won't go into detail here, and tomorrow from Craig Lee on the formation of the Arctic Ocean Regional Alliance Aurora, which are important elements for the future coordination of Arctic research in the marine sphere. We have been also working, as I said, on enhancing different knowledge, the inclusion of different knowledge systems, so science and indigenous knowledge and local knowledge. Here we have been supporting the arcticseas.org website, a very exciting website which is hosting a lot of experiences and observations of indigenous communities and coastal communities around the Arctic Rim. And as I said earlier, we have been supporting Say on Roads with the development of the shared Arctic variable concept, with topics dealing with wildfire, with permafrost, and with sea ice. The idea of these shared Arctic variables, if you haven't encountered them yet, is what kind of things need to be observed to handle a certain problem, a certain issue in a better way, and then to find ways how to fund it and to implement those observations. In the terms of bringing the Arctic data system into action, which was led by Met Norway and the German Pangea network, a lot of activities have been done on mapping the polar data system, transformation of data to standardized form. Nice thing for scientists who get help in making their data standardized with partly automated, semi-automated systems. Fair data and service provision, long-term data preservation, all these elements are important. And we have been supporting the data center harvesting for the unified Say on Data portal, which is also an important thing which will carry on into the future. I mentioned those services we have been developing, 8 of them. One was an indigenous-led event database, reporting on events in their vicinity, in the vicinity of their communities, around the Arctic Rim, based on oral histories, indigenous knowledge, but also community-based monitoring with modern equipment. An example here is the Taltan Climate Events Database. You can find more on that on this arcticseas.org website. The team at AVI in Hamburg, in Potsdam, has been developing a pan-Arctic permafrost change database called ALEX, on detailed information on landscape changes due to permafrost thaw. We have a state-of-the-Arctic environment information hub developed here at NPI, and down here on the bottom right, an integrated fire risk management developed at CNR in Italy. Then there was a local atmospheric pollutant forecast service developed at JRC in Italy, an improved safety for shipping in polar seas service. You see, it's a really wide range. Please have a look at our website later on when you want to learn more. Another co-creation which happened with hunters and fishers in Greenland, in Karnak, was the Arctic Marine Climate Change Noise Pollution Impact database, which was set up and deployed, and a lake ice climate change and safety service developed in Finland. And then, of course, we also were working a lot on connecting to policy, but also connecting with each other in the Arctic observing community, let's say. So we have been working on policy briefings. We were creating recommendations to funding agencies. We have been creating a sharing circle with young people around the Arctic, indigenous people, researchers, indigenous scholars, people from administrations, to connect and to share their knowledge and their visions for the Arctic. All of that was really important to create a network, and this is something we continue to tell ourselves, and hopefully others can be convinced of that too, that such a large EU project, by the way, it was not only funded by the EU, but also had a co-funding from Canada, that the creation of the network itself is already a kind of legacy of the project, not only the products and services which have been done. And we hope we can build on this legacy of the network in the future. We have created a number of fact sheets on different aspects from the project, and you later on can grab one. Arild brought a package of those where you can find a little bit of summary on what we have been doing. And we have a lot of online data and information available for all of you to grab. We have a website. You can find the QR code here. You can look into our deliverables on different aspects of the project. And we just recently finished with a synthesis and roadmap for the future Arctic Observing System, or as we call it, the Pan-Arctic Observing System of Systems. Please download it on our website. It summarizes a lot of the activities we have created, and also leads you to some of the deliverables with more detailed content and more context. So where do we go from now? From here? As I said, we ended the project in December. Part of what we put down in the synthesis is a kind of vision for a sustainable and useful Arctic observing system and systems. And these visions, as well as the policy recommendations, which I will come up with later on, is not only based on what we did in the project. It is also based on many, many discussions with other organizations, programs, people working on Arctic observations. So it's really the result of a lot of discussions over almost 5 years in the context of Arctic observing. And what we think is really important is that an AOSS in the future is holistic and inclusive to create meaning for the people living there and meaning for the people who are using those data. We think that it's necessary that the network bridges society, policy, and science. There's still not enough interaction between those fields of human activity, but we need to foster those. We need to make sure that the scientists are talking with the people in the region. I mean, Arctic Frontiers is a perfect example for how this can be achieved, but we need more of that. Also with people living outside of the Arctic, to bring those to their attention. And this is even more important in these days of increased tension and conflict, that we need to build on the network of the willing organizations and people. Sustainable and coordinated long-term observations, that's something which we think is really important. Still too often, long-term observations are funded by short-term science contracts, and we don't get the sustained observations we need for understanding, interpreting what's going on in the Arctic on all fields. So this is really an important element of a future observing system. Community observations, local observations are an irreplaceable element, not only in terms of scientific understanding, but also in linking what is done in science and research with the people living in the Arctic. A multilateral and connected AOSS, well, that's a given, of course. We want to make sure that it is really an internationally combined and integrative networks. Data systems that are fair, care, and trust compliant and actionable. That is still a gap. For sure, you will hear more about that in the coming presentations. There's still a lot to do. Strong science policy communication channels. That is something which refers also to this network to bridge society with science and policy. Empowered indigenous and local leadership. We need funding mechanisms which allow this indigenous leadership, local leadership of research projects, but also being part of the governance structures. And we need them to be resilient and adaptive in times of change, not only of climate change and change in nature, but also political and geopolitical change. Which then brings us to the recommendations for the policy, which sound a bit similar naturally. So we think that we need to prioritize inclusive and holistic approaches that create meaningful impact. This is something which is not only on the agenda for the politicians, like all of this, but of all of us, also as researchers and funding agencies. Again, the sustaining of long-term observations with dedicated cross-disciplinary funding, the enhancement of coordination and governance of the Arctic observing system with diverse and equitable approaches. We need to make sure that local and indigenous people are, or indigenous peoples and other Arctic inhabitants are part of the governance of an observing network to make sure of the Arctic. An important connection is to really make sure that the satellite networks, the remote sensing products are really useful for the people on the ground. There is still a gap which needs to be closed, which we want the politicians to support. In the end, it all boils down to what are the funding structures which are available, which topics are funded, and also how is the, let's say, political support of those ideas. We need to foster structured science policy dialogues for evidence-based decision-making. This is something where I hope that we can get into more conversations with local decision-makers. I will say a few words in 1 minute as the last slide on an upcoming new project, a kind of follow-up to Arctic Passion, where we are very happy to have the Arctic Mayors Forum, ICC Canada, ICC Greenland, and Sami Council as partners, where we hope that this connection between science and local decision makers can be strengthened. I already mentioned the empowering of indigenous and local leadership in observing systems is something we also asked from the politicians. And when it comes to investing in innovation like AI and other elements, it's important that these have ethical safeguards and that we focus on the connections between the people who will, let's say, benefit or suffer from those innovations when it comes to the observing system as well as in other societal parts. Okay, and then secure and sustainable coordination structure, I already mentioned that, and the link of the Arctic observing investments to global policy frameworks. And with that, I come to the last slide, and this is our new project. We are very happy that the Commission has been able to fund another project which is dealing with improving the Arctic observing system. And here we have Beyond Arctic Passion coming along, starting in September, with a number of activities which build on what Arctic Passion and others have been doing. But also a lot of new elements, and this is where I'm going to stop. Thank you.
Great, thanks very much, Mikael. This is a good place to start with an overview of the complexity and diversity and ways forward. So, very good. We have a few minutes for questions. So, our help in the back can provide microphones to anyone who raises their hand.
Hi there. Thank you for a great presentation. I'm left with two questions about the things we choose to monitor in the Arctic. And I speak sort of on behalf of a lot of sort of worried community voices, but there are two aspects that I am suggesting, and I just want to hear your thoughts on monitoring first car tire particles in the Arctic.
Well,
and the second thing would be kelp forests and the kelp extent in the Arctic.
mm-hmm.
And I wonder if you have any such thoughts on monitoring those things also.
Yeah, I understood the kelp forest question, but what was the other particles?
Air transported car tire particles.
Car tire particles.
So
yeah.
perhaps you know the biggest
like
source.
microplastics and other tiny pollutant bits. Unfortunately, we have no dedicated program on that. There are a few research projects which take care of that. There's the Arc Solution project, which is led by the Nord University with a strong participation of AMAP, who think about emerging pollutants and existing pollutants and how they spread into the Arctic via air transport as well as via marine transport, including microplastics, PFOAs, these eternity pollutants and so on. About car tire particles, I don't know any specific project. Maybe we can use the connection to the Arc Solution people to find those programs. About the kelp forest, I think it could be possible to talk with people here in Norway, maybe Camilla Bratland from the University of Tromsø. I would assume that she has connections to those, but they are not part of Beyond Arctic Passion, unfortunately.
Thank you. Getting maybe ahead of a later discussion, but I just Googled the Arctic Passion project and reading the EU funding page, and it says that there were 36 participant organizations in the project. I want to touch on your point about projects being funded through short contracts and there a need for a longer term commitment. But for a project of 36 participants across many different countries, how are you going to navigate establishing a budgeted funding commitment, the necessary for long-term funding?
Yeah.
How do you divide, especially when the European Union is providing the original project funding? Do you have ideas?
Well, yeah, we have ideas. Unfortunately, it's not in our hands how to actually, make sure that the funding is going on. But we have been and will continue to do so, lobbying for continued funding. We are in contact with the Copernicus Network from Europe, which is one of the, let's say, agencies or organizations which could handle those long-term observations. They do so in connection with ESA, for example, for the satellite network. We do have examples from the meteorological world that these ongoing long-term commitments are there. We don't have that for terrestrial or marine observations yet, but we hope that something will be done in the future. We have been developing, together with the so-called Arctic Science Funders Forum, recommendations to the nations who are in the end the funders for such activities, hoping that they will pick up on that and that they will make sure that there is a European, let's say, at least framework of long-term funding for infrastructure in the Arctic. There are programs coming up in that direction, but so far we don't have any continued funding network active. Yeah.
Which Met Office is most interested?
Which Met Office?
You said you were lobbying, including with the different Met Offices. I was just curious, which organization is the warmest?
No, I said we are lobbying towards Copernicus, for example, and we are lobbying together with many organizations. And as part of Arctic Passion, for example, the Met Offices which were involved are the Norwegian Met Office, the Danish Met Office, the Finnish Met Office. Yeah.
Great.
Done?
Thanks very much. You're done. Your
Thank
time
you.
is up.
Thank you.
For the time being. And thanks very much for keeping the time, Mikael. That allowed us questions. So for the remaining speakers, if you do manage to stay within the allotted 8 minutes for the presentation itself, there will be time for a question or two also for you. So with that, I welcome Kate Hortensi. Are you here? Yes, you are. Great. Yeah. So while you make your way comfortably, Kate is a PhD candidate with Dalhousie University in Canada, and her research is focused on how marine protected areas can be designed to protect relationships between people and the environment in the face of climate change. Welcome, Kate.
Thank you very much. Will you kind of timekeep for me?
I will.
Okay, great, thank you.
Yellow shirts in the back.
Oh my gosh, perfect. Okay.
There's the clock over there.
Now you're off the
10
hook.
minutes starts now, not at
Okay. I imagine you're all going to have a little bit of whiplash in this session, going between very, very big scale to very, very tiny scale and back and forth. So I'm on the very tiny scale side of this. So my name is Kate Hortensi. I'm originally in Canada for the last couple of years and now live in Lithuania. I do interdisciplinary work, understanding benthic communities, and my work is extremely place-based. So I work in Nunatsiavut, Canada. This is right on the Labrador Sea. It's about the size of Scotland for some European reference. It has about 17,000 kilometers of coastline, about 1,800 people. And there's lots and lots of commercial work, understanding the benthos right beyond this line, but not so much on the inside. And there's a lot of gaps when it comes to understanding the benthos within the region. So just because I'm assuming we're not a big room full of benthic researchers, a little bit of a primer for you. To understand what the bottom of the sea looks like, usually we take these big boats and we scan the bottom with sound waves, and then we take machines out like this to then see the pictures of the bottom and then put the two together to get maps of what the habitat looks like on the bottom of the sea. So this is a very crude drawing of what I'm going to describe to you as the problem here. So the way we do this is that usually you have scuba divers that go down and take videos or do transects to understand the bottom of the sea, but the problem is that they can't go very deep. It's also very expensive and can be very dangerous when you're working in remote, cold places. The other option is having large research vessels with ROVs come in, and that's a great option for deeper waters, but in shallower waters, there's also a problem. There's lots of hazards, and it's really expensive and dangerous to bring your big machines that are worth millions of dollars down there. Not only that, but boats don't usually go there because these waters are uncharted, so it's risky for the boats as well. And then that's even before considering the problem with the ice. There's always, most of the field season, these waters are ice covered and are pretty inaccessible to both of those means. So that leaves us with a lot of gaps of what the benthic ecosystems actually look like in these very heterogeneous polar regions. But whether there are actually gaps to understanding is really a matter of perspective. Lots of fisher people fish cod, char, rock cod. They harvest crab, elks, seaweed, urchins. And so then you start to get a really good picture of what the bottom of the sea actually looks like. So to do this work, we use that as the foundation. Understanding the relationship between Labrador Inuit and the bottom of the sea are extremely important. And so from that, we used a framework of relationality, which means relationality values the connection between people and the natural world and prioritizes accountability within these relationships. So to do this, we got a bunch of GoPros and then just used supplies that we could find at the local store to make these GoPro rigs. And we advertised basically a GoPro library in the 5 communities in Nunatsiavut. People could come out and borrow GoPros, take them for the weekend, take them for a week, bring them out to their cabins, take some videos at the bottom of the sea, give that back to us, and then we analyze those videos. And so here's just some pictures. There's me and a couple different scenarios doing this. And the thing I want to emphasize is that we went where community wanted us to go. Usually the community was taking them out or I was with them, and were places that people were interested because stuff was going on there. And the sea, we were fishing or we were scallop dredging. It was interesting stuff that people were already doing in those places. And as a result, we got lots of interesting videos. And so in total, there's about 122 videos that we collected from across the Nunatsiavut coast of lots of different plants and animals. And so I really want to emphasize that we were doing this in an iterative process with community members. And so we built a Facebook page called What's Under Nunatsiavut Waters. This was for us to post videos, do little surveys, actually maintain relationships, like when us as researchers weren't actually up in Nunatsiavut. Not only that, but Oceana and Fisheries and Oceans Canada and other people started posting their videos of the benthos to this page as well because they had an opportunity and a forum to then provide this information and give it back to the community in a fun and interesting way. And just some science results for you. Because of this work, we were able to establish 8 different community assemblages. And so these are like neighborhoods on the bottom of the sea. And each one of those has an indicator species. And something I really want to emphasize is that these are indicator species of the they indicate the relationships that, sorry, let me rephrase this. Each one of these communities and their indicator species, that data is inseparable from the relationships in which they have with Labrador Inuit. So you can't separate the people from these results. And one interesting thing about the process that we were able to do here is we were also able to capture the benthos across seasons. So there's lots of heterogeneity that we don't really understand about the bottom of the sea of how it changes over seasons. Because we were able to deploy these GoPros through every single season, we were able to better capture that and also see lots and lots of migratory species that we've been able to see otherwise. So this was really great and really in a lot of community engagement and a lot of interest in the benthos in Labrador, in Nunatsiavut. So, yes, I want to, because we're here talking about observational networks and observation, I really want to put in a plug that this is observation in relation to Labrador Inuit knowledge and experience. And so on this scale, we were really able to integrate community needs and also this foundational, fundamental idea of what we wanted to see and what we were looking for. So with that, I think I flew through that because I was so nervous about 8 minutes, but hopefully that'll leave us some time for questions. Yeah, and so the idea of this is really to understand and get an idea of what relational change looks like and to map the change in relationships when it comes to the change, for example, in climate change. And so this is really important, and when we come to the question of what we decide to measure, what we're deciding to observe, understanding the relationships in which community have with these plants and animals is fundamental because these are value-based decisions, and understanding that the values that were coming into these decisions can really have a big impact into A, the processes that you take, and then B, the results that you get. So, Nakumik, thank you very much, and open for questions. Free right here.
That was great. Thank you. I'll be presenting in a few minutes, and you'll see it's very similar.
Awesome.
So You obviously have a deep connection to this community. How long have you been there?
4 years.
4 years. And are you committed to just going there?
Well, I just moved to Lithuania, so my life just changed drastically. And so one of the things that I'm interested in would like to do is take this principle and the foundation of understanding, implementing relationality in science, because it's such a big concept in health science and in social science. But we don't really talk about it because natural science is supposed to be so values neutral, to really talk about the values that underpin all of our scientific decisions. So I'm pretty passionate about this now, and I'd love to see how to translate this into, for example, permafrost networks, how to translate into these. I think the concepts here are very transferable to other regions and other things in which we're looking at observing, especially with climate change.
There's still time. Yeah, thank you. That was awesome. I'm curious about those initial results that you were showing, and if the community, if there's any surprises, if they're already, noticing changes that you're kind of highlighting there, and like how things used to be as far as species abundance and stuff.
Yeah. So I don't have. I have a poster coming up in the next poster session. Just a little plug for myself. But this is one part of a larger project, and one of the specific parts is looking at relational change over time. And so one of the things that came up in that was really interesting when you separate like change in abundance, for example, from change in relationship, you get very, very different results. Because a change, for example, when you're talking about Atlantification or borealization, more and more seaweed on the bottom of the sea, that may, even though that might be a really big change in a region and you might see a lot more seaweed, whether or not that's changing, making relational change between Labrador Inuit and the resources they use is a different question. So the methodology that we're using here is trying to answer that fundamental question instead of looking at the dots in the network, looking at the lines between them to understand how the change is happening. So in that space, there were surprises. But in bringing it back to community, they were like, oh, yeah, that's cool. Okay.
Great.
Thank you.
Sorry for scaring you with the timekeeping. That went really well. I hope the others will be equally, frightened. Perfect. Next up, Jon Rosales, climate change scientist at St. Lawrence University in the US, focused on the impacts of climate change on native peoples in the Arctic. Remote control there, and microphone, please.
Okay. Thank you. It's very good to be here. I thought I'd use black as a background just because we've seen enough white first day of this conference. So similar to what you just heard, I am going to make the case that there is already an observing network. It's been around for thousands and thousands of years. It's still functional. It is not static. It'll change with time. We just need to recognize that and include it in our efforts. So UXIC is the name of my project, our project. It's a Siberian, actually St. Lawrence Island Yupik term, means to turn quickly to avoid danger. We think that's what we need to do with climate change. So please say the word UXIC from the gut up as you enjoy your dinner here and your conversations here. UXIC is also an acronym that stands for Alaskan Sharing Indigenous Knowledge. We started in 2009. Our tagline is we're Native Voices from the Front Lines of Climate Change. We study the impacts of climate change in the Bering Strait region using indigenous science. And this is going to be my plug is indigenous science, and this is beyond co-production of knowledge. Our research methodology is we start with the tribal councils. We think that's the only way that we can honestly do our work. Yes, we go by a lot of the research protocols that are published out there, but you have to go to the villages and talk to the leadership there, and then the elders is what we do second. And then we develop research methods going out into the field. So here are two learning areas. These are not study sites. I don't go there to extract knowledge. I go there to learn about climate change. Shaktoolik on the mainland of Alaska and Savungas in the Bering Strait on St. Lawrence Island. This is Shaktoolik, and as you can see, they're very exposed. It's a one-road town, 250 people, houses on both sides, but they're very exposed to storms. So when we started this work back in 2010, 2011, I asked them, what here? And they said, study storm surge. So then the second question is, okay, how do you study storm surge? How do you monitor storm surge? And it became obvious to us if you look at the front of their village. They get a lot of driftwood there. They're not too far from the Yukon River outlet. So any new storm will bring a new driftwood deposit, and they said, go ahead and map it. They'd map it themselves. They actually put stakes in the ground. They'll put a little year on it. They monitor it this way. And from this method, we were able to storm surge maps of old driftwood deposits out on beyond Shaktoolik, and we showed that the 2011 storm actually would have inundated the village. The winds were a little bit offshore, so it didn't happen. And then the 2013 storm was a little bit stronger yet, going beyond the village itself of Shaktoolik. And then we also then mapped it for what structures within the village themselves would be most vulnerable to similar storm surges. These maps are now helping Shaktoolik receive funding to get a road to higher ground, an evacuation road, and some other emergency services funding. So this was very important to them. But my research questions started with them identifying what to study. The other example I want to highlight is from Savunga. Here's Savunga on St. Lawrence Island. And to them, one of their top concerns with climate change is the changing wind patterns. So traditionally, they tell me that the winds are coming out of the northwest, but now those winds are coming from the south and the east. And you can imagine that those prevailing winds have a tremendous impact on sea ice. Sea ice is very important because that's where they hunt whales and seals, and that's also where they'll find the whales, or walrus and seals, and then the whales are there too. So we started doing that up there. We looked at the grass out on the tundra, and the elders taught us that if you look at the dead grass, that is a measurement of the prevailing wind direction. We set up a similar experiment at St. Lawrence University in New York. There's our weather station there, and we've actually been able to measure the grass lay direction now for 5 years, and this is in prep. We're going to publish this pretty soon. But this is the wind direction here, and that's the grass lay direction, and the R-square is very high. Let's see, can you press that? That's a video. Yes, thank you. So now they have us looking at live grasses. And we set up this station, like I said, at our living laboratory. We were able to grow the same grasses that grow up in Alaska. This is blue joint grass, and it's leading us to some really interesting results. So we only have 1 year of data for the blue joint grass, which is the one that we are studying up in the Arctic. It took a year to establish it in 2 plots. The smooth brome is a native grass of New York. But that 1 year of data is revealing something interesting here. It is the directionality of the blue joint grass is bending toward the prevailing wind direction. Okay, so we are measuring these culm nodes down here on the grass blades themselves. And our hypothesis is that the grass will grow and bend into the wind to remain erect. Now, if any of you are a botanist and you know about this, please come and talk to me. But as far as I know, it's the auxins that are straightening this out. But that's another indicator of prevailing wind direction. And then with smooth brome, this is 2 years of data, and it's pretty consistent from the southwest. Next summer, we're going to go out to these locations on the island and start monitoring and measuring culm nodes and grass lay direction. So throughout all this research that we've done up there since 2009, it led to this thought in my mind, and this is why I submitted this abstract, so thank you for accepting it for this panel. But we have learned there that a robust indigenous science has existed on its own since time immemorial and is poised to be used as a research methodology throughout the Arctic. These methodologies are novel science, and sometimes they can unveil surprising results. And I'd like to end with this, with a thought of where does this fit in the academy, within academics. And I'm going to use triangles to portray this. And I'm going to suggest to you that this is moving away from disciplinary, multidisciplinary, interdisciplinary research into transdisciplinary. So if you imagine knowledge in one field of study like physics, economics, it may increase with time. You may partner with a couple researchers to explore something like a zoologist and economist working on the value of wildlife through multiple disciplines. You may incorporate or consider many disciplines in a study like reconstructing deforestation trends from landscape paintings. This may take you into many different disciplines where you literally blend all of them. But this is what I want to leave you with, is that knowledge exists in many, many, many forms. Each one of these waving lines could be economics, physics, it could be non-human knowledge. Transdisciplinary knowledge kind of taps into this. And it really prompts us to question what academics is, what knowledge is, and who can claim knowledge. So I'll just end there.
There's time for one question.
Well, here are my village coordinators who I couldn't do this work without, and funding. Thank you.
Great, thanks very much, and I hope you will be around so we can talk to you later, if not questions right now. Right, next up is Annelien Lennart. She is an environmental anthropologist at UiT, the Arctic University of Norway, part of an interdisciplinary group of scientists working on the ISOSCAN project, combining isotope hydrology, modeling, and citizen science to improve the forecasting of extreme hydrometeorological events in Scandinavia. Nothing less. Floor is yours.
Okay. Thank you. Oh, that's the wrong one. That's your slide. Do you want to begin before me? It's okay.
Yes.
We can just switch.
Mixing up. I was so much looking forward to your presentation also. Please come on. You're not Annelien.
We can switch it up. You
Yes.
want to do mine, I'll do yours. It
Yeah,
might
that could be interesting. Matthew Ballax. Matt, welcome.
Thank you.
You are at the Geophysical Institute at the University of Alaska Fairbanks, and having spent time screwing up the order of things, I will let you introduce the rest.
Yeah, so my name is Matthew Balash. I'm at the University of Alaska Fairbanks, and I serve as the Deputy Director of the Alaska Coastal Cooperative, which I'll talk about here. And I just want to start off by thanking the acceptance of this abstract for this session. I mean, the talks so far have just been incredible, the overlap between what we're all doing. It's really inspiring. So I want to talk about a project that we are in our third year of. It's called the Action Project. This is funded by the National Science Foundation. Action, it's a bit of a mouthful, and quite honestly, we chose the acronym before we figured out what the title was. But it does stand for the Alaska Coastal Cooperative for Co-Producing Transformative Ideas and Opportunities in the North. And then so the first part of that, the Alaska Coastal Cooperative, I do want to spend a brief moment talking about who we are, because we are new. We founded ourselves in 2022. As I said, we're housed in the University of Alaska Fairbanks. And we really have a threefold mission. So we're working directly with communities along the coast of Alaska. And our priorities is to enhance the communication between all of the different actors that are working in the coastal communities, but most importantly with the communities themselves. And our real goal there is to make sure that the priorities and the needs of the communities are risen to the top and informing the science that's being done. And then on that note, we also want to advance the sciences, both social and physical, but with the, I guess, the key caveat of actionable science that's useful to the communities and that will serve the communities. And then lastly, something that is universally asked for is engagement with the youth, as well as technical training, which I'll speak to here in a moment. So the action project itself, we are working with 12 different communities, 11 in Alaska and 1 in the Northwest Territories of Canada. The project is quite large. We have 4 different universities on it, as well as state and federal agencies. But one thing I do want to highlight here is the direct cooperation with the community. So all of the communities have PIs on the project, but also community research leads, or what we call CRLs. And these are funded positions on our project. There are people who live in the communities and are really leading the charge of identifying what the priorities are, what the science is, and doing the science. So I do want to highlight one of the large events that took place last summer, and that is what we call the Convergence Research Cruise. This was on an icebreaker, and we went all over Alaska. We started in Seward down to Chiknik Bay, where we had a community visit. We stopped in Atka with the community visit, did some shore work outside of St. Paul and Hooper Bay, and then another community visit up in Gamble. The Convergence cruise was really special. So on the cruise itself, it was split right down the middle. We had half Indigenous partners and half Western scientists, and we really took this opportunity to learn from each other on the cruise itself, to understand what is going on at the community levels, and as well as doing all sorts of different modules, training modules. So this was a 16-day voyage, so there was ample time on the ship to spend together, in addition to those community visits. So unfortunately, with the 8 minutes, and I'll try to keep it at that as best I can, there's not too much I can talk to, but I did want to highlight 2 in particular, especially for this crowd. So one is the oceanographic work and the hydrographic surveys that we did. And then the other one is what we call the methods of braided surveying, which we'll get into. So the hydrographic observations, there was a lot of work that we did do on the vessel, but one that I want to highlight is the implementation of these spotter buoys. So these are low-cost buoys in the grand scheme of things, somewhat disposable, if you will. But we worked with each one of our communities to identify spots that were important, to understand what the water level was, whether it's an important spot for fishing or for traffic or navigability. And we deployed these buoys in those communities. And it was really trying to address the gaps in the data, if you will, especially in Western Alaska, where it's quite sparse to have water level data. And one of the things that came out of it is this last fall, unfortunately, there was a large storm. It was remnants of a tropical storm called Halong, and it decimated several communities along the western coast of Alaska. But these spotter buoys were actually used by the National Weather Service and other community members to look at the surge, the rising water level, and some of the models were used for that. But one of the things that I think is even more important than the modeling that our Weather Service did is the actual use of the data and the use of the sensors. So that's another really important thing. Every time we're deploying instrumentation, we're trying to think of how it can be used by the community. And that's really important that it's accessible and usable by the community. And this is just another example from the Chiknik area, the first stop of our cruise. And this is water level sensors that are used to inform tide. The nearest tide station is hundreds of miles away, and it's off by more than an hour. So this is a pretty useful piece of data set for the local communities. And quite frankly, people are 2 minutes left. It says 4 here. All right, I'll speed it up then. Okay, and then the last part is the methods of braided surveying. And so at our last talks really kind of highlighted, this type of methodology where we're incorporating all sorts of knowledge systems, not just the physical and social sciences, but also the indigenous and local knowledge. So during our community visits, and we had 3 of them again down in the Chikniks, Atka, and Gamble, we used our time on the ship to work with, to hear from our community research leads the importance of the area and to understand a sense of place, of why the places that we're studying are important. And then we really spent a lot of time discussing it, pre-planning the surveys. and then spent some time on the shore collecting the data and summarized everything in group discussions at the end. So I do want to highlight just one really quickly up in Gamble, also on St. Lawrence, as we were just seeing in the last talk. And this is, we did a number of different data collections, but one I want to highlight here is we used commercial off-the-shelf fish finders to do bathymetry mapping or water depth mapping. And this was something that was done by a different community on our project. And that kind of also underscores a really advantageous thing about our cruise is the community exchange and the community knowledge exchange. So this was the community of the Chicknicks project to incorporate it out in Gamble to meet their own needs. So we adapted the methodologies to best serve the community. Okay, so in the little time I have left, I'll just say a couple key takeaways. So again, the priorities of the community and the projects being led by the community are at the forefront of what our philosophy is on our project. The data collection itself by the CRLs is also in that category. And then the last thing I'll just mention is once the data are collected, the co-management of the data and making sure that it is accessible, as we heard from the other speakers, is paramount. So I guess I'll leave it at that. And thank you.
So there is 2 minutes for questions. That's why they asked you to speed up.
Ah, okay, so that was the 8-minute countdown. All right.
If there are any questions, please go ahead, and you better ask something now because
Yeah.
microphone, please. Hang on a second.
Hi, I wonder how much the communities learn new things from the other communities.
Yeah, that's a great question. So, boy, I wish this was a 20-minute talk because there was so much that was going on there. Everything from the actual physical sciences to cultural practices. One of the fan favorite is in Atka we went on a reindeer hunt, and we actually brought a reindeer onto the vessel and butchered it. And so there was a lot of different community exchange between, across the spectrum, both the physical sciences, the example that I mentioned in Gamble with the surveying, different methods that were used by the different communities. But also, even the social and cultural aspect of things. So we had an ongoing module where we had different crafting and the different methods that were used in the different geographic areas of, just even within Alaska was pretty incredible. So there was a really rich discussion and exchange of knowledge between all the participants. And not just between communities are indigenous to indigenous, but just all together. It was just a really rich experience.
Great, thanks very much. And without further ado, an introduction, Anneli Lennart, UiT Arctic University of Tromsø, please.
Let's see if we are lucky here. Okay, yeah, so thank you for having me here. I'm here on behalf of the project ISOSCAN, and I'm going to be talking about scale engagement and data quality in Arctic snow sampling and testing the ISOSCAN citizen science framework. So these are results that we have had from the first year of testing this and how we can make this work. So first of all, ISOSCAN in a nutshell. So what is ISOSCAN? Well, you said the subtitle, or it's isotope added assessment and forecasting of hydroclimate extremes in the Scandinavian through stakeholder co-design. So what is it we want to do? So the scientific background are these large uncertainties that exist in relation to hydrology, etc. So we want to be able to better predict the extreme weather events that are happening. That can be floods, etc. that happen in Scandinavia as well. And for this, we need water isotopes to better provide analysis and data to forecast these now we're focusing here in the Scandinavian Arctic. So how do we get more data in a large geographical extent. And that was what we were working with. Because to get these predictions to be good, we need a large area. We need to get samples from a large area and geographical extent. And we researchers, we can't be here all over. So for this, we thought, what can we do here? We wanted to test something else, and we're in Tromsø. There's a lot of people who go outdoors. They go skiing. There's a lot of tourists. So we thought, maybe we should try citizen science. So there we worked on developing a scalable, effective citizen science framework that both involves recreational nature users, both locals, visitors, tourism, so they also in some way can contribute in a positive way, leisure, stakeholders, and also the hydropower sector to help overcome these lackages that there are in the isotope data. So what we did was that we had a lot of different meetings. And what we wanted to do was that we wanted to co-design the best way of doing this. So here we invited all these different groups, and we did looking at maps, building with Lego, drawing, etc., so that we could get to know each other. But you can imagine what happens when a natural scientist or a normal person, a hydrologist, environmental anthropologist, citizen scientist, and also with different languages when they meet. Well, it's confusing. You have to really understand each other. And it's sometimes you can feel overwhelmed because are we actually speaking the same language? But at the end, it actually became a really nice line here, and we call it a fuzzy co-design process. It's like when you're painting your house or renovating, you just feel, oh my God, I'm never gonna get to the ending of this. So what we saw was that there are more parties involved in citizen science that we think at first, and those are things that we have to think about, and also that research and science is built on a relationship. So we can have the professional scientists, so the hydrologists, meteorologists, the labs, the technicians, or the citizen scientists, which can be the locals, visitors, tour guides. It can also be school children that we're working with, that all have these different things that they want out of this project. And to address all these people and the way that they perceive things, one needs to be flexible. Because one has to think, like, how does one secure good samples when we think about research? So natural scientists, in the beginning, they wanted the samples to be collected with plastic spoons, put into plastic bags, melted somewhere, and then poured into a veil. That was the first thing they were thinking. But then we have the potential citizen scientists who has no time to melt the snow, maybe in the front, in the front of their car, or the dog water who needs something fast, or the tour organizers who want something fast as well. So there was a lot of different considerations that we have to think about when we think about making things, especially also this kit there we're gonna be talking about. And then again, one had to have meetings again and talk on how do we actually get this to work. So what we actually developed was this fantastic tool here. I would say these are actually the natural scientists that were really, really good in designing this. So this is a sample kit. We made some cards and also an app for people to register. So that was that. Okay, we got that going. What we also got was that we got actually really good data. But what about the citizen scientists? What did they get? And what we saw was that often the things that happen is that things don't align. So citizen scientists, they want to know what happened to their samples quickly, how they benefited, and how it benefits science and society. And the scientists, they of course need to analyze the samples. It takes time. They need to model it, and yeah, the data will be available in months or not, maybe also in years' time. So what did we learn here in our test period? Well, we learned, you can see, a lot of different things, but that citizen science in many ways can fall short. Oh, sorry, there's something lacking. Oh, and what can we do better? Oh. There's a slide missing here. Can I go back? Yeah. So what we actually saw was that people, they would take the samples here, but they would not deliver them back. So 91% took the samples but did not deliver them back, we found out that it's important to have a good collaboration and dialogue with the pickup points, that we need to invest time with people and also the places that, hand these out, and that we need to build a community. So it's not enough just saying, oh, thank you for becoming an ISO scanner, that really you need to build a community of practice, and that we have to share the outcomes faster than one actually does, that they feel that there's a meaning about this. And what are we thinking, or what are we going to be doing better this year? So we're going to be upscaling, of course, but we have been using time to more invest with the local people. We're having workshops when we're delivering these. We're also going to be working with schools and scouts. So we're going to use time more with students and see, is this a way of building a community with youth and making them take the surveys as well? So, yeah, thank you. Thank you.
Yeah, thanks very much. Another perspective on observing. Next up, Alberto Roldan Sastre, recent master's graduate from University Center of the Westfjords, Iceland, focusing on marine mammal monitoring using state-of-the-art methodologies. And you will explain more in depth yourself. Please go ahead.
I will do it in 8 minutes, yeah? Okay, good. Good afternoon, everyone, and welcome to this talk about assessing the status of ring seals in Western Svalbard through machine learning. Breaking news, we are losing the Arctic, although that's something that we've been aware of for the last 25 years. Within the high Arctic, the Norwegian archipelago of Svalbard has been highly impacted by the increasing inflow of warmer and saltier waters into the western fjords of Spitsbergen through the Spitsbergen current. Despite our knowledge about these processes, how these changes are affecting Arctic marine mammals population status and trends remain unknown for most species and regions. Ring seals are the most ice-associated species as they rely on sea ice and snow for all stages of their life history. They inhabit the landfast sea ice habitat, where they create layers in order to nurse and raise their pups. However, projections towards a warmer climate are expected to reduce the available breeding layer habitat for ring seals. For this reason, they've been classified as a vulnerable species within the Norwegian National Red List. However, despite this consideration, the current status and population threat of this species remain unknown in Svalbard, with the last abundance estimates dating back to 2002. This gap in the literature is a consequence of missing adequate techniques in order to conduct monitoring surveys in these remote and challenging polar regions. The recent development of drones, or UAS, have made these monitoring surveys more accessible and cost-effective. However, aerial surveys are quite time-consuming and expensive, is time-consuming and expensive. So, in order to overcome these disadvantages, we can use machine learning and specifically computer vision models that are able to detect target species after being trained on a specific data set. Based on this, we propose two different research goals. First of all, to explore the potential of computer vision models in combination with UAS surveys to automate ring seals aerial monitoring. And secondly, determine if the population of ring seals has changed in Western Svalbard over the last 20 years, and whether contemporary internal estimates are consistent across fjords. So in order to train these computer vision models, we conducted aerial surveys using drones in selected fjords in Western Spitsbergen, including Kongsfjorden, Isfjorden, and Van Mien-fjorden between 2023 and 2025. We analyzed the images, detect the seals, and label them in order to create a customized dataset called ProSeal that we divided in 3 different sets. 70% of the total of the images for training, 15% for validation in order to assess the learning process of the model, and 50% for the test set in order to evaluate the performance of the model. For each set, we divide the images into tiny sub-images, as you can observe on the screen, which are required for the training, validation, and test. When we evaluate the performance of the model, we are based on two main metrics. First of all, precision, which quantifies the proportion of detections that are correct, and recall, which quantifies the proportions of true positives that are detected by the model among all potential targets. So in this case, we prioritize recall as false negatives, so seals that are not detected by the model present a greater problem than false positives, because these false positives can be discarded by manual verification of the detections provided by the model. So when we evaluate the performance of this model in its own test set, we observed a precision of 94% and a recall of 84%, which indicates its great capability to detect most of the seals without detecting many false positives. However, we also create an external data set composed by a number of images, one order of magnitude larger than the test set, in order to evaluate the performance of the model on a representative large enough data set. This table summarizes the performance of the model under different confidence and intersection over union threshold, in which our best result indicates a recall of 96%. Further analysis of the efficacy of the model suggests that the human workload can be reduced by almost 100% from the fully manual verification of the sub-images in the external dataset. Therefore, this model achieved the goal of the project of reaching a high recall while maintaining an adequate false positive, true positive ratio. Once we improved the monitoring process for the ring seals, we wanted to estimate the abundance of these seals on the different fjords. Therefore, by making use of the Landsfass sea ice extent maps provided by the Norwegian Meteorological Institute and the fly logs from our aerial surveys, we calculated the total sea ice extent in the fjords and the total area that we surveyed within the fjords. Given the proportion of area that we surveyed and the number of seals within the images, we calculated the total amount of seals that they were hauled out on the sea ice at the time of the survey. However, in order to account for those seals that they were underwater diving at the time of the surveys, a correction factor was applied in order to calculate the total amount of seals within the fjord. Then these values of abundance, density, and Landsfass sea ice extent were compared with the values from the 2002 survey that I mentioned before. When we compare the Landsfass sea ice extent between fjords and years and with the Landsfass sea ice extent from the 2002 period, two main results can be observed. First of all, there was a great variability in the Landsfass sea ice extent between fjords and years, as we can observe in different fjords such as Konfjorden and Isfjorden. However, some fjords remain relatively stable over time, as we can observe in Diksonfjorden and Vemmenfjorden. Secondly, all fjords experience a marked decline in the Landsfass sea ice extents since 2002, as we observed with an average reduction in Kongsfjorden of 56% in Kongsfjorden, 65% in Isfjorden, and 76% in Vemmenfjorden. Focusing on the abundance of the seals, when we compare the abundance of the seals from the 2002 survey with the average estimates from this study period, we observed an average reduction in the number of seals of 63% in Kongsfjorden, 62% in Isfjorden, and a 48% in Vemmenfjorden. However, when we examine each fjord individually, density and abundance patterns show variability for the same fjord across the study period, suggesting the influence of different factors, such as fine-scale local characteristics of the fjord, as well as variance in the environmental conditions from year to year. Overall, although annual abundance estimates show variability, there were no significant changes in the number of ring seals were observed over the 3 years study period. However, abundance estimates across all surveyed fjords remain consistently lower than those reported from the 2002 survey. Therefore, a feasible hypothesis is that the declines in the number of ring seals have been driven by low PAP survival and recruitment as a result of suboptimal sea ice and snow conditions, predation, and early sea ice breakup. In addition, this species suffers the pressure from sport hunting, which could partially explain the declines observed in this study. Lastly, some individuals might have emigrated to other areas in Svalbard, further increasing the declines observed in this study. Based on all previously exposed, we can conclude for the first goal of the project that the model developed in this study has a great potential for accurate, rapid, and low-cost automated monitoring of ring seals in aerial images in combination with drones. Its deployment could substantially reduce analysis time and operational cost, demonstrating that more frequently drone-based monitoring surveys are feasible. For the second goal of the project, we provided an update on the ring seal status in Western Svalbard, confirming marked declines in abundance and landfall sea ice extent in Isfjorden, Kongsfjorden, and Bambienfjorden since 2002. The lack of information in Eastern Svalbard indicates the need for further research in this region. Lastly, we demonstrated the spatial and interannual variability in ring seals abundance and density, suggesting the need for a multi-site monitoring approach in consecutive years for accurate ring seals estimates. Thanks for your attention.
Thanks for keeping the time. There is time for at least one question.
Try my best.
Hi, thank you. That was super interesting. I have a question about drone operations on Svalbard and how you dealt with temperature challenges or weather challenges, if you did, and how that went.
Are you asking me because of my accent?
No.
Well, basically, we count with like all the equipment that you use from the Norwegian Polar Institute is keeping us warm. Obviously, it's a challenge, but you just get adapted to that, no problem. I guess it's just a matter of spending time on the field work.
I mean, specifically with like drones with batteries not working
Well,
cold.
obviously, they are limited. So in this case, for the drones, we have a limit of around 1 hour for the flights. The colder it gets, the lower is going to be the battery endurance. So right now, we are working with lithium batteries, but we have seen that there are some advantages, although they are using like fuel. So we are contemplating using these drones in order to survey extended areas and so on. But still, it's a matter of like funding and at the same time being able to conduct these surveys. Yeah.
Thanks. That's a lot of questions.
You can go for a coffee later as well, don't worry.
Because we are out of time, right? So I don't know. So
one question and a short answer.
Okay, I hope this can be answered quickly, but I'm curious about how you navigated the regulatory environment around using drones, both on Svalbard and in general, and also how you see that impacting the ability to use them further for bigger projects.
Well, obviously we follow the regulations for drones, so in this case we fly them below 120 meters, so we cannot go higher than that. Definitely it's a limitation, especially with the cameras we have, because we fly at that altitude in order to take a proper coverage of the fjords. But it's something that we are trying to implement or like to test. If we are flying lower, we're still able to cover enough fjords, and it goes along with the batteries that we were talking before. It's a trade-off between the altitude, the camera resolution, and then how much coverage we want to take, because obviously, as we are not covering the whole fjord, we need to take into account that for the proportions later on to estimate the seals. So it's a bit of a tricky aspect, but we're working on that. Okay, thank you.
Great, thanks very much.
of the, now I have to pull my voice back. About the Distributed Biological Observatory in the Pacific sector, and then the expansion to bring back to the Kale's original talk on the Pan-Arctic network of DBOs. But my co-authors here are Lee Cooper, also from the institute I'm at, and UMSES, Karen Fry from Clark University, Christina from St. Mary's College of Maryland, and Sue Moore from the University of Washington. So for the DBO, for the people who don't know this, we initiated this in 2010 as a pilot program based on some long-term measurements that have been going on from the 1970s. And so it served as and developed as a change detection array, as you can read in here. It combines biology, physics, and chemistry because you can't study the biological system without the key drivers in there. So everyone, when we go out to sea, and this is an oceanographic collections here, we're doing measurements of temperature, salinity, chemistry, ocean acidification, nutrients, down to zooplankton and phytoplankton taxonomy. And this goes across institutions and internationally. So the way we built this was to work with the Pacific Arctic Group. We had a big meeting in Ottawa on that group. We decided where are we going, what ships are going there. We built a heat map and figured out what kind of measurements we were doing and how we could build this monitoring system. So then we collaborate by having both dedicated ship platforms and shared platforms as far as collections are being made, US, and you can see all the different flags on the bottom. The different ones have slowed down because of certain aspects of our political situation. But we're continuing and implementing this as a Pan-Arctic network. This will be my concluding slide. So I would just point out what you're seeing here on the left is the satellite. As we all know, satellite description, the fact that the sea ice is going out earlier in the spring and it's coming back later in the fall, and you're seeing color-coded as much as to 2025, which is the yellow. And then you can see the observing sites, standard stations going all the way up and up through the Northern Bering, Chukchi, and into the Canadian Arctic. So what you're seeing here, we work a lot with our scientists with NASA, building these maps. On the left is looking at the annual production. What you're seeing here is the green, obviously more productive, moving into the Central Arctic Ocean. But the field program is all on the continental shelves. And then on the right, you're seeing the productivity changes. And I would just point out that DBO1, which is just south of St. Lawrence Island, so it was great to hear about that. We have worked with folks on the island for decades now. I actually did my PhD work in this region from the University of Alaska Fairbanks. And anyway, you can see here as well as also north of Bering Strait. These areas, their ice is going away earlier. We're getting more primary production, but a lot of that is being actually grazed out by the upper water column work of the zooplankton. And then just an example. So as I said, when we're going out, we're looking at nutrients. You're seeing ammonia, phosphate, nitrate, silicate, salinity. And by the time we're there on this particular cruise in August, we have a cruise in July that we also do, but it's subsurface chlorophyll max. So we're not picking up all of that by the satellite information that we have. And you can see the very warm water in the surface waters here, and this is southwest of St. Lawrence Island. If you go through and you look at the time series, the benthic populations, what you're seeing, this is giving you just 20 years of the 40 years time series we actually have. And you can see just by color coding what the dominant animals are. Clams being in the brown, and you see these guys up here now, and marching up from the Northern Bering into the Chukchi Sea. The main point I'd like to, since about the 2010, 2015, we've been seeing these declining populations of food that's important for both diving sea ducks as well as walruses in the region. And we're potentially impacting the food supply for these types of upper trophic organisms, and this one particularly in walrus is a key food source for coastal communities. In the DBO2 region, I point this out, this is north of Bering Strait of St. Lawrence Island now, because this is also a prime feeding area, has been for gray whales. And what you're seing here is a contraction since the 1970s. And so, so this is the prey base here. This is in the purple. This is what you're seeing. Just the 4 areas are our time series that we built in. Prior to that, we had process cruises when we wanted to know what the area was like. But in order to be able to go from a south to north with the observing system, then we have a subset that we track. And what you're seeing over time is the contraction, 70s, 80s, 90s, 2000, 2010. This year, we're having another unusual mortality event for gray whales in the past. And the work we're doing at the prey base is declining. They're moving further north to feed, but they don't have these amphipod-rich, lipid-rich, caloric content prey. That appears to be a major impact on building up that blubber that they need to be able to go back down to the lipids to Mexico, have their calves, come back up north. So that is something that we're seeing, another indication of a change in system. Again, this is now north of Bering Strait here, and you're seeing the very rich, this is the Anadyr water, high nutrients, low temperature, and this is working now between Point Hope off to the dateline here. Once again, subsurface chlorophyll max at this time of the sampling, and very warm water along the coastal area. If you look at this sampling over the time series, very rich area here when we used to work with our Russian colleagues, and hopefully at some point in the future. But right now, we don't go into that side of the western part of the Chukchi, but we are able to track the changes in the benthic populations, indicative, and this one has not changed that much. In fact, the biomass, I would point out, is 3 times as much as we see anywhere else in this side of the Arctic. It's extremely rich for benthic feeding upper trophic level, such as walrus, bearded seals. And then as you go to the coastline, you get higher diversity, lower biomass. This is very warm water now, low nutrients, low production. 2 key points I want to bring up is this area is being hit with harmful algal blooms now. Warming seawater, declining sea ice. These are toxic dinoflagellates that are produced. They cyst over in the sediments and then come back with the warmer water. And this is having an impact on prey base, but it also has a health issue for coastal communities. So when we're out on the ships, we have an IFCB, which is able to do real-time monitoring, works through Woods Hole, provides data. We don't contact the local communities, although we provide them daily reports. It goes through if there's an issue, it goes through the medical system. And you can see the other part is ocean acidification, as we've seen, 0 time. Okay. And I would close up by saying that this is we do marine mammal and seabird observations on every one of these cruises. What we're seeing is that the gray whales are feeding further north, but the prey base isn't as strong up there. The other thing, we're seeing subarctic humpback whales moving north and feeding in this area. This is critical because of the fact of ship strike issues. And the other thing is the U.S. building their only deep water port in the Arctic in a very shallow Nome system. So it'll start this year, and that'll have, because shipping, commercial shipping, LNGs are coming through in the wintertime too. So the bottom line on that is we're seeing more gray whales going north, but the prey base is not as strong for them. Humpbacks are now in competition because gray whales are starting to feed, may also be feeding on krill, at the same thing that humpbacks are going after. And then walrus and polar bear are spending more time, or many a time, going onto land for haul-outs and then going back out to sea to feed. And then I would just close up, because I know I'm over time, this is the Pan-Arctic network of DBOs. And we've been working with our international colleagues on, we work on multiple ships from Canada, US, Japan, Korea, previously Russia, and China, occupying these at various levels throughout the year. And then we shared those data at meetings at the Pacific Arctic Group here. We've had multiple data meetings, just like the Atlantic DBO had their most recent one here, I think it was in Tromsø, correct? But the main thing I wanted to point out is that we've been building this international network here, developing, hopefully continuing on the Baffin Bay, Davis Strait, and then the Siberian DBO, as we will have the 4th Pan-Arctic Community meeting at Arctic Science Summit Week in Aarhus if any of you are coming to that meeting. And with that, I will just, since I'm talking too much, say thank you to all the collaborators. Point out there's a lot of information here. If you go to the DVO website, the data sets are all publicly available, both through these two major sites and then the funding agencies. Thank you.
Perfect. Very nice way to conclude. I'm afraid there's no time for questions now, but Jackie will be around the whole week, so you can grab a talk with her later on. So I will not try to summarize anything at all, just remind you that tomorrow I hope to see you all for the second session of this topic, starting at 9 o'clock. Øystein will be the convener, and in that one we will have fewer presentations, but a panel discussion, hopefully also with time for questions from the audience. So in that session, we bind it all together and look forward together. Thank you.